Okay, we're going to look at assignment 11, and we're going to do the last one, number 75. So it says a child on a merry-go-round sits on a horse that is 5.6 meters from the center. So in my given, I know that the radius is equal to 5.6 meters. At top speed, the merry-go-round completes 10 revolutions every minute. So what I'm going to do is I'm going to write what I'm reading. 10 revolutions per minute. Now remember that I'm always going to do a horizontal line like this. Okay? So my revolution is not a unit. A revolution is a word that's describing what this object is doing. So that's actually the frequency. Now what I can do is I know that the period and the frequency are reciprocals of one another. So what I can do is I can go ahead and reverse this and say 1 minute per 10 revolutions is equal to the frequency. So anyway, so now I always want it to be, and again, this is just a word, it's not a unit. So now I don't want minutes, I want seconds. So if I put minutes in the numerator, I put minutes in the denominator, and there's 60 seconds and 1 minute. So then when I do this on my calculator, 60 divided by 10 is just 6. So the period is 6 seconds. And that's also in my given. And that was actually question A. It said determine the period. Question B says determine the child's tangential velocity. So the tangential velocity is 2 pi r over t. So it's 2 pi 5.6 meters divided by 6 seconds. So when I do this on my calculator, I get 5.86, and then I look at my unit, I have a meter per second, which is the correct unit for velocity. So 5.86 meters per second. And then part C said determine the child's centripetal acceleration in meters per second squared and g's. So first we'll do it in meters per second squared. So the centripetal acceleration is v squared over r. So that's equal to 5.86 meters per second squared divided by 5.6 meters. So numerically, this comes out to be 6.1, and it's supposed to be a meter per second squared, but let's just check our work. So when I square this number, I square the unit. So I have meter squared per second squared divided by a meter. So I end up with meters per second squared, which is the correct unit for acceleration. Now we want to know the number of g's. So this was 6.1. I think I had 3 meters per second squared. So our conversion factor is, I know 1 g is 9.8 meters per second squared. So this cancels with that, and then that'll give us the number of g's. So 6.13 divided by 9.8 comes out to be 0.626 g's. And that's it.